I'm trying to insert succeeding board. Find in child positions succeeding board. That is not end, then child positions already contain succeeding board. What is child positions? Version 1, white to move data. Child positions underscore must be a member. That's version 0, and it's simply not showing version 1. That's a CTEC bug. Here's the version 1 child positions thing. That's black to move data. Version 1. This is black to move. What am I doing in this file? White to move data. This is the only place where I add something to child positions. It's being called from here. Yep, namespace version 1. Data. So data is a white to move data. That means that current position must be white to move. Current position comes from color to move map. So this must be inside something where color equals white. Generate edges with color. That's type is 1. I think that's white, yeah. Yep. Generate edges. I have absolutely no clue. So I think what I can do maybe is run it in the debugger and then run these two in parallel. So two programs at once in two debuggers. And then step through it and then compare them-ish. But that will only work, of course, if they print a lot of debug output at the same time. Otherwise I get nuts printing everything. So I'm gonna enter here, and then everything that is being called must call debug output. Let's see what is print so far. So this part is the same, version 0. It calculates at least the same things, and actually you're comparing the whole graph and every board exists. The size of the graph is the same and every node contains the same board. Or at least every node appears in the other version as well. Then version 0 is doing this, generate edges, called of course with 0. Why is it printing 0? But okay, that would be black. Number of positions in color to move map 1488. Number of positions in other to move map 7496. And then it is called with a 1 and it's the other way around, obviously. What? Why is this again version 0? Must have done something wrong. Yeah, I forgot to change this one in a 1 to go 1. No, so far so good, I guess. I mean, they are both called. This is called, same order, same output. Next, it runs over this for loop. If we return from that, we're done, right? I mean, it goes wrong in that function. So this, yeah, it goes wrong in an add edges. Beauty mark. No, it's debug. Space debug. It's a big function, but yeah, it's a template. It has to be in the header. I don't think I can print current position. This is an iterator, right? Let's just take it apart like that. Print the board. Oh, what the fuck? I think I want to print the data as well, though. A lot of output. Okay, the working version 0, looking over all positions in color to move map. That's a lot of them. Just printing bits, it's a bit vague. Don't even know what that is anymore. Oh, that's a classification, yeah. No, good to have a check that the classification went correct. I think the only thing that I did is check that the board appears. Apparently made and moves is not set yet, of course, I would almost say. Yeah, I should start with checking that the classification is the same as well. Because that could cause a difference. Let's begin with that. So in graph1.cxx, iterator. Iterators found. Second assert. Iter. Let's see. Iterator find is just an iterator, so that is an standard pair board and data. The board must be the same, obviously, because I looked at it up like that. It's not that easy to compare though. I can assume that is true. So the second must be the data. And I want that to be equal to, where's my closing parenthesis? The data must be equal to the data that we looked up or took a apart here. Looking that is board 0, data 0, obviously, yes. But that's version 0, black to move data. Now I have version 1, black to move data. How can we compare those? This is not filled in yet. at that point. Just the classification should be filled in. So I compare them by the classification, because that's the same, right? No, also not the same. Dang. But the bit should be the same. The made a moves was not set. I just have to extract the bits then. Which I cannot do. I can only do this. Well, let's add it. I need an accessor for... Shall I just check all of these? It says 4 of them. Classification. What the hell? Oh, Was ist denn das? There must be different colors, I guess. So this data 1 is version 1, white to move data. And here we have version 1, black to move data. And then there should be again... what? That is black to move data, yeah. This is white to move data. Okay. I think that succeeded. So the bits are equal as well. Let's see how quickly that goes wrong. Well, yeah, about a page. And then I'm printing even extra data. One, two, three, 4, 5, 6, 7, 8, 9, the 10th here. One, two, three, 4, 5, 6, the 7th. Yeah, the ordering is different. And the map. Would that be the reason? Can that be the reason? So a few calls that were already done here have not been done yet, but this is for a very different position every time, I think. Well, not that much, but at least the rook is in a different position. Hello, MAI. Well, I guess to print more debug output. What happens after this? Yeah, I guess. Yeah, I have no clue, actually. What child? You have a child position. That is the succeeding position. The position that follows after doing a move. For the life of me, I can't think of a reason why it would fail. The only thing I can do is just print more. Compare more. Okay, so this is... Yeah. Let's make another mark. This makes an indentation. You can also set a marker. Actually, it does set a marker at the beginning of the line, so it indents with a certain character and a space. So add another marker here. Some extra indentation, and I'm printing just all the ports. This is, I can just print it. I really need to learn in Vim better. How do you set a marker? I keep forgetting that. It's M. MA. Nobody knows. Good enough. So, bum, 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 bum. Down here we have this. Oh, we can jump even like that. Print the current board, and then this, and then this. And then this inside the loop. So now I print all the succeeding boards. Your question. Bum, 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 bum. Do you like the casual implementation of the SCUF method? I have no idea what that is. So, can't answer it. Succeeding boards, that. Okay, let's see what the output is. No, hardly. Every now and then if I don't know something that I could look up, then I can ask an AI. But not for the stuff that AIs get wrong anyway. This is version 0. Current board has 24 positions, and then it prints all 24, I suppose. Yes. And let me get another one for this one. Yeah, but it's not the interesting thing, right? Only this board is really interesting. Okay, also 24 positions. Seven? Okay, we have a bug. 7 is nonsense. I think the board is 5 big now. So the largest coordinate can be 4. So then the succeeding board returns nonsense. So the previous one was correct. Yeah, just... well, yeah, -1. Oh, what? Huh? Oh, maybe the -1 is returned into 7? Yeah, but it would also influence other stuff. Okay, nevertheless, probably not a good idea to try to return -1. Maybe the 7 is -1, but yeah, then still, Black King should be 0, 0 for all of them, and we're getting 7, so that's not good. Right, yeah, succeeding boards gives me coordinates that go outside the board. Ah, now we solved the problem. That is the reason. We have only 3 bits now, because then we have only coordinates as 0, 1, 2, 3, 4. Just 5 things which fit in 3 bits. And this thing goes past 8, which doesn't fit in 3 bits anymore. So 8 becomes 0. Is that where it goes wrong? Something like that. Related to that. Let's see if we can compare this list. Copy it. But even the first one, 0, 0, 7, 7. Why? It must have been borrowing it. That's what. Yeah, the y coordinate. Yeah, the y coordinate is -1, and the y coordinate is the most significant bits. So the most significant bits turn into 7, but it borrows also from the black king. So this -1 turns the zeros into 7 and the -1 into 7. Now I can stop there, of course. That's the reason. Then afterwards, I'm updating the white king position, but the black king isn't even touched because it remains 7-7. Okay, yeah, that's definitely the bug then. Good. So this is the problem here. Whatever. Grab sources. So this is where it goes wrong. I'm passing here stuff that doesn't fit. So what we should do is that, and as soon as this does not fit, we should not add it to the result, because it's an illegal position anyway then. And then again here. And again here, I guess. So what you could do is change the set white rook square to return a boolean. Maybe. Could throw an exception even. Might as well return a boolean. Gonna do if this succeeds, then push it. Oops. Yeah. Ah no, this is already inside board. I should do the test here. Let's see, so if this is not clamped within the correct range. Might as well deduce that here. A minimum and a maximum value. And so the dx min, if that dx itself, let's see what kind of equation do we have here. You have this, right? This. And that must be greater or equal 0. And so if it is less than 0, then dx is too small. So for min, this is equal to 0. Or larger, in which case it could be -1, but in the edge case, this can be not less than 0. In other words, this is minus that, the minimum value. But of course it cannot be smaller than -1. So the standard max of -1 and that. Which means that if this is 1, then you can subtract 1. If it is 0, then this becomes 0. You cannot subtract 1, and if it is larger than that, that also becomes yeah. This works, right? And then for the dx max, you get that must be a standard minimum then, because it's on the other side, which is probably clamped between 1 and. Let me get the same comparison again. In this case we have again this, of course, but now max, and we should not get larger than board size -1. So this, and then minus that is the other one. For the max thing. And here we have the same thing, but then with the y replaced by x replaced by y, I mean. This doesn't matter. I think I can put it completely outside the loop. CBKY, yeah. This is the same thing. different. Okay. Accept that now it's a black. Sorry, it's a white king. Nou ja, we just move the rook in any direction from the current position. So it is C central current in this case. So the white rook x coordinate is the current white rook x coordinate, and the same for the y coordinate. And then we move it in a certain direction. So as soon as we go off the board, then every subsequent distance is also off the board. So I should just break when we reach that point. And I'm kind of already checking that. So what I could do is replace the white king coordinates here with also yeah, something else if the white king is not on that line. The only advantage being that then I would have just a single test and we do the calculations outside this loop, but is it worth it? Yeah, why not? Let's say we run in a certain direction and the limit is independent of the x or y, but it is dependent on the limit, on the direction. So I'm gonna say there's only one limit actually. Is that one limit? So if we subtract, we go in the negative direction, then we cannot allow it to be -1. And we cannot allow it to be board size if we go in the other direction. And that then depends on the direction we go into. We could add 2 tests here. Depends on which one. Now you can argue that I could replace either this or that one with the limit. But no, that doesn't work because it's test both. It's an AND. Let's keep it simple. I can make it simpler though. I can just change the dist. You can pre-calculate it. So what I wanted to do is if WRX becomes equal to the limit, then break. However, breaking means just exiting this loop. So if we restrict this maximum size of dist to something, then this will be the effect. The only question is then, how can we calculate, no, not limit, but end. So how can I calculate this value? Well, that is easy. So first of all, this is end. And what we want is that this is less than end, yes? So as soon as it becomes equal, then we shouldn't have entered it at all. And WRX can be written as, well, that is just WRX, it's just this thing, plus this. Must be less than end. Which means that you can subtract that from it. Both sides. To dist. There's -1 or 1. Take the absolute value on both sides, right? So this must be less than the absolute value of end minus that. Yes, of course. Or not. Yeah, no, that is correct, I think. Where's the logic in this? However, the difference between these two, the current position and the end, so it is on the edge and we go in that direction, then it would be 1, must be less than 1, we cannot step. Yeah, that's correct. And the other end here is board size itself, or board size. This is kind of the step that we can take, and then we cannot take a step. Yeah, it's the same thing, right? I'm not 100% sure, I must say, but I think that this should be good. And then the question is, can this ever be larger than board size? Well, no. Or less than minus board size? Also no. That is -1 minus board size -1. The board size -1 is board size plus -1, and then subtract that is -1 minus -1 is 0. So it is minus board size. Well, so we can just replace this. Except that they should not use CWRX, but we should use the variable that so if vert equals 0, then we use that one. Otherwise we use the other one. Yeah, I think we have about 80% chance that this is correct, and 0%, I mean. Oh, wait a minute. Just a missing handle. Still 80%. Now, if I could only remember where standard min is defined. Algorithm, I'm gonna guess. Or not. Standard min. Utils then. Yeah, it must be utils. I'm just gonna edit it. Last attempt though. Utility, I already have a utility. I give up. It was not this one, but then what is it? Possible. Must be one of those. It is algorithm. Must be something else. What is the error then? The actual error. No matching function equal to min. Candidate templates. Oh, see, it does have min. Int versus unsigned int. That is the problem. Different signedness. That's what you get when you define something as unsigned int. Make it an unsigned int. Where does that U go then at the end? What the fuck? Yeah, okay. Otherwise it was a variable name, right? Still no go. The same problem, of course. You know, we get the same problem everywhere. Yeah, no more assert. Actually, let's have a look at the same output, see if now it looks same. So this is version 0 and this is version 1 and we have now 0, 0, yay. The -1 is just gone. Only 13 positions? And, oh, print 13, but yeah, we only get same values that are within the board. But that's a good thing. So, did I already change it that I use version 1 to do the moving? And over all positions for 0 and 1. Should probably test if they're equal again, right? That is a bit difficult though. Okay. I'm just going to move the comparison down. So the generate edges is one thing and then the number of ply. It's done here or set maximum ply. Oh yeah, yeah. Okay, let's do it in little steps, as in we first check the generated edges. It's already fixed this stream. So that would be the add edges adds. That adds stuff to child positions. And parent positions. So we test this, but we also have to test the other thingy. I need to get we can run over this and then both of them and then convert it to a board again. It's pretty damn difficult that the boards are so different that I really have to take them completely apart and reconstruct it. to do the same thing as I did already, but now for every iterator of both of these. Talking about slow. I only have to do it once, and then if it works, it works. So let's add an add an iterator here. Accessor. I mean. Parent positions. What to do? Let's start here. No, let's just get that. What does this return? Too difficult. Something. Well, it must be an iterator. Now I have to do the same thing as up here. I have an iterator. Let's see. Here. Here I already have a board. There's a board data. There's a dereference iterator. Let's just shadow it. No. And then we do all of this. Get the squares, get the coordinates, recreate squares, and then recreate the board. Let's begin with that. Okay, let's begin with this, checking that the size is the same. So I reconstructed the board in version 1, and then we have to verify that that exists in data 1 child positions. So auto iter is what child position is a vector, isn't it? Yes. Standard find data 1 child positions begin, comma, child positions end. Find if. I think that's calling some callable that takes a value type of the thing, which is an iterator, but you can do auto anyway. Which then should return a boolean for if it is found. I'm having child board 1, so you can just compare the board directly here. So the dereference I is so an iterator of this versus the board equals child board 1. So we just search in the map, that was easier. And then we say it must be found. And then we checked even the content. Well, the content of the map, because that contains more than just the board. In this case you have let's first see that the board is there. So iter is unequal that. Yeah, that's good enough. What else do we have then? Oh yeah, no, the same thing for the parent. So if this is correct, then the parent will probably also be correct. I'll hardly have to check that. Let's just not do that. Or is it easy? It's kind of easy, isn't it? I just copy this and then replace child with parent. That's just a problem with reviewing. So if you write this, and you just do a copy and a paste, and then you do a replace of child with parent, and you are 100% sure that if the code worked for the child, then it's going to work for parent. And then you write, do a commit, and then you pull request. And then the people say, yeah, but I can't merge your pull request unless I review it. And since they don't know how you created the code, they have to look at this as hard as in the code above, because they are not aware of the fact that this is constructed from the code above. So I think that it would be beneficial to have a language where you can just do that. To basically say here something like that in terms of the language, exactly the same as the above, but then with child replaced by parent. And of course that is possible in C++ if you use templates, but yeah, nobody does that. I mean, maybe I do sometimes. If I see this is code duplication, no matter how you look at it. It's just debug code. It's pure test. I'm gonna delete it tomorrow, basically. That's why I'm not having a problem at the moment with the code duplication. Otherwise, the code duplication is so bad that I would completely avoid this. If this was a production code, no way. And then I would have to rewrite it such that this became a template where you just have a child or parent template parameter, and then you don't have to duplicate it, of course. Then it is duplicated for you by the compiler, but a template instantiation. But I just in other cases you can't even do that. You know, it's just Sometimes it's really important to know how code was generated instead of just typed in. It's kind of missing a part, I think, still in the language. Talking about code duplication, now we have to do this again for the Y2move map, right? Because all of this is now part of the black2move map. So this was added. And then it must be added again here, and then I probably have a white somewhere. And another white. This white must be black. Am I even using that? Got the feeling I'm not using it. Nope. Still leaving it in. Could add an assert that it matches with the ply, but this is just for the edges. The ply comes after this. There is no parent positions. What? Black2move data. And again. Where's this? In. Version 1, black2move data. Really? Same file. A little bit down. Compile. Nope, does not compile. No welcome version from version 0 Y2move data to version 0 black2move data. Yeah, okay. So I change this to white, but not the type. And then this probably also should be white. This must be black, actually. Perren, oh, nonsense. That must also be white. I cannot remember that I changed the color at 2 places. What? This is black, so then the child position is white. And the parent position is also white. And then we get the same thing here, right? So this one is white, so then the child is black. And then the parent is also black. Yeah, there it is. This one must be black. Cannot implicitly capture something. Well, we want to capture this by reference, why not? Cannot implicitly what again? There's even more of them. There's probably 4 of them. I only changed 2. That's code duplication for you. I'm punished for using code duplication, and it compiles. Da, 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 da. I know. Let's see if it does not assert. Hopefully, it's not assert. Dang, it does assert. Oh, the child positions are not the same. Oh. They play by different rules. One has more moves than the other. One. Okay, let's see if we can figure out. Well, this is correct. Version 0 is correct. So he does know how to calculate size, but I want to print it. No. GDB crashes. Not useful. Op 7, what was it? Print data. So this is not 1. It is 0. And I can't print data 1, or can I? Nope, cannot do anything with this debugger. I need a better debugger. Yeah, I think it's enough again for today. Let's play a game of chess. I think so long, man. The opening is still happening. Is that possible? Probably. Yeah, it is possible, isn't it? Give check, knight comes here. My plan was to play bishop here. But then it can just take a check. That wouldn't work. Though I win this pawn back then. So take. Queen is attacked. Take a check. Take, check again, and I attack that knight. Maybe I win a piece like that. Okay, so I do this, he goes there, bishop here. Threaten to win a pawn here. If he takes my knight, I kind of have to take back with the queen here. While the knight is still pinned, it's all possible. I can't calculate it, so I'm going to try this because it's just intriguing. Well, this is a given, right? And then if I pin it, then the question is, so if they take here, and if you take here, I take that thing. And then we're equal. I don't see the problem there. Say bishop comes here. No, that is attacked. So the knight goes back, and then I still win here, or probably. It's not bad. Take with the bishop, more logical. It's check. Then, oh, it's check. Yeah, then I take back. It's no problem. And the only problem would be that then the knight takes. But then I take check here. Pawn takes, check, and I win the knight. So if they don't take back, I also have a pawn more. A piece more, I think. I don't know. Let's just try it. I still can't calculate it. So now I'm totally threatened to take here. Maybe just immediately the bishop. If then I take, and then it takes here a check. And okay, I can also take a check. So take a check. Queen takes. I still can't calculate it. It doesn't look good. I think bishop here is problematic, kind of. I would have to defend my knight. I can, of course, now I move the bishop, I can just play the knight here and then I have defended that. Exactly, there is no problem. It's good. It's good. The only thing I really have to watch out for is that if he takes the knight, I must be able to take the bishop. So if black now castles, then that is the threat. Knight takes knight. Say castle and I take this knight. He's not going to take back. He just takes here. Attack the queen. No, then I can take the bishop. Actually, yeah, still, if I take the knight. Castle, I take the knight. Then I can take the bishop again. Yeah, now it's pinned, but then could just take it. Castle, I take here. Yep. And we won't see this happening because I'm gonna win on time, apparently. Okay, so I take here, and then he has to take here a check, and then take again a check. It's horrible for black. Yeah, I must take, right? Yeah, not that horrible. But no problem, because I can now just defend this pawn. Try to keep the bishop out of this square as well at the same time. Maybe put some more pressure on here, so the bishop must stay there. Well, it doesn't must, but the queen is also defending it. But or I can go here and stop them from castling, but then this pawn comes and then I have to go away anyway. Still, I think this is not that bad. So keep an eye on this square and on this square and on this square. And I'm not even giving away my queen for some reason. As expected. So now I can just draw back and putting more pressure on that. Keeping the pressure. So now he can castle, but on the long run I hope to be able to keep the bishop here away from this square. At the very least. I can play my own pawn. Or I can just castle. Totally going to castle the next move. Yeah. Oh, what is that? Go back. Here I'm doing nothing, huh? Or if I go here, it could develop the rook like a ding ding. Then we have a problem. I think I'm just gonna go here now. But then the bishop comes here. Cheat. Hook lift. Yeah. Now I'm down on time. You gotta be kidding me. I just castle. Hello ND. I have 34 seconds left. No time to talk. Oh shit. Oh shit again. Oh, what the fuck, dude. And I'm losing on time. I'm dead. Fuck. Fuck. Yeah, mate. Does not want to give mate. Oh, I want to give mate like that. Yeah. Shit. I hate those guys that play super slow and then in the end they start playing very fast. Ugh. The absolute horrible game. Was not a good move, apparently. He also developed the rook better. Yeah, it's a bit fancy to bring the queen out. This was the best move though. And then bad move again. I could just defend my knight here. Developed an undeveloped piece. How simple can it be? Yeah, and now I got into trouble. Giving a bit advantage away now. It's minus 0.2. Minus 0.1. And I'm doing this horrible move again. What should I have done? The queen? Why? Why the queen? Oh, because then I threatened to take here. Yeah. I should have taken. I know it. Yeah, this was absolutely was a blunder. Too much time pressure here. Giving away this pawn is losing. Minus 5, so totally losing. Minus 14, but it was already losing. Mate in 4, mate in 3, mate in 1, mate in 7, mate in 7, mate in 10, mate in 9, mate in 5, mate in 4. Mate in 1. I saw this one. He didn't. Yeah, I gave away this pawn with check. That was the super big blunder, which I should not have done. I'm gonna read what ND said. I have a curious question if you're open to discussing it. I've been learning programming indirectly and realized I really like numerical approximation methods. I'm a bit lost since it's outside of my main profession. I'll learn quite a bit by example and reading books, so I didn't know if you have any advice to give. I've interacted a bit with C++, and I think I'd like it if a lot if I knew where to start. numerical approximation methods. Not what the first language that you think of then is not C++. Yeah, I know, man. If you want to write a serious program that does that, then you just have to use a library. And the best libraries are written, I don't know, Fortran. That's not coding Fortran. But C++, maybe there's something, yeah. If you only want to play with it, then I'm not even sure what you ask. You ask for a book or you ask for an idea to code in C++? Or you left already? Oh no, she's still here, I think. Yeah, I've done very little, I think, with numerical approximations. I do like exact approximations, so finite field stuff. But if you say numerical approximation, the first thing I think of is floating points, and I usually stay away from floating points. I did do my university graduation though on that topic, but that is a long time ago. I wish I still had my my graduation report, because it was incredibly difficult. I had done some measurements, and what was it? The idea was that I needed to do some numerical integration. Yeah. I don't know. I can't remember it anymore. The only thing I remember is that it was at the very limit of what I could do. And then multiple times, so I was working on something until I almost gave up because it was too difficult. And then I had an insight, and then everything came together. And then building on top of that, that happened again and again. So that's yeah, I don't think I ever did anything more brilliant in that subject. But unfortunately, how would you call it? Whatever I printed in the end as being my thing, I don't have it anymore. Otherwise, I would love to look at it once more. Yeah, it's dissertation is PhD, right? It's above a normal graduation. You probably should have moments like that in that case for a PhD. It's kind of PhD level. No, what I did is what I did, for example, what I find quite interesting is I wrote something with related to elliptic curves, aka finite fields. So theory starts, I guess, here. So yeah, I just this was all new to me. So more or less did figure it out myself, and then brought it under words, made a description, which is then this website. So it has lots of stupid examples. So of course, well, what a finite field is, and then what a field extension is. And then at the same time, I wrote a program that comes with it. So that gives you really a big understanding of the subject matter. Now, if you just write this and this is the only text you have, then you can never say you really understand it. But if you write a computer program that does it, then it's you master it. So I know where you're coming from. That's definitely very nice. Yes. But this is not a numerical approximation, right? It's just playing. But again, I took this very far, and I hope I can show you exactly what I did. So I need an irreducible trinomial. So that's one thing. Which then turns out to be very closely related to a random number generator, but aside from that. The Frobenius map. So I guess this. So you have all the elements of the finite field, and if you square it, you have the same elements again, but then shuffled. And the funny thing is that if you do that for anything, the equations still hold. So you have some random equation, you can just square everything, and then the equation still holds. That is Frobenius. And then they use that in calculating the trace of a field element. I mean, trace of a matrix, everyone knows what that is. But the trace of a field element, I've got it again, what it is. If I read this, I probably should know again what that is. And then I found out that was really a discovery of me. Let's see if I see that written down somewhere. Oh yeah, I found out an insane fast way to calculate the trace of a field element. So if you have this field element, t to the power m plus t to the power k0 plus t to the power k1 all the way till t to the power kn plus 1, then the trace of tj, that is that field element, is 1 if and only if j is odd, and there exists an I such that j equals m minus ki, or when j equals 0 and m is odd. Which you can do in 2 clock cycles, right? Or 2 assembly instructions or something like that. And that had to do with the solutions of an elliptical, solutions over an elliptic curve, or of an elliptic curve over a finite field. It's also too long ago for me to really be able to explain it. I'm looking at this page like it's new, as it were, yeah. I'm looking for the nice graphs. So now we have a trace of a field, and then you can define a polynomial. So this is just well, this is just a class, I guess. So t is a root of an irreducible trinomial or polynomial of degree 5. Sometimes you need it. So t is the solution of a third degree polynomial, say trinomial over a finite field. But you cannot necessarily write down t because it's, you know, it can be a several pages long square root thing. But then you can write down all the polynomials in t to up to the degree of the irreducible trinomial, which is called I forgot that too. You set that trinomial to equal to 0, so that is the reduction polynomial, something like that. Yeah, reduction polynomial. Or a pentanomial. So then finally we are ready to do elliptic curves. Get a Golov field, elliptic curves. Point counting, points being the number of solutions. So you have an x and a y, which are both element of the finite field, and then x comma y, so two field elements, form a point on an elliptic curve, which solve the elliptic curve equation. Call highlighting that, but elliptic curves, yeah, kind of this. We have an a and a b, and x and y, a and b are all element of fq here, this finite field. And then the question is, how many solutions does the thing have? Which is impossible to calculate, but I could brute force it. So I brute force it for everything, basically, starting for a very low degree. So m is 3. Doesn't really matter which irreducible trinomial you use as the reduction polynomial. The structure is always the same. So this holds for every elliptic curve of degree 3. But yeah, now what do you know? I mean, there are in total 56 curves, depending on what you pick. And then there are 4 of those curves have only 4 solutions. And 4 have 14 solutions. And there's 12 different curves have 6 solutions, and 12 have 8, and 10, and 12. But yeah, okay, you know, nice. And then we go look at n is 4, and then you see this. Now it looks still symmetrical in that this 24 and 10 solutions both have the same number of curves. There is an asymmetry here in the fact that these are C3 times C6, while the rest is cyclic. But if you ignore that, and it's totally symmetrical. And then you get n is 5, degree 5, degree 6, degree 7. Now, by now, everyone believes that this is totally symmetrical in this line, in the vertical line, right? And as a side note, everywhere I said that these numbers, the number of solutions, if you take the greatest common divisor, then that is equal to q divided by 2. That turns out to be the case for in everywhere. So these things, the height come in batches of q divided by 2, where q is the number of elements in the finite field. And later I also found why that is the case. It's very trivial. Still the case here. So you can read the conclusion. So from this brute force data, we already draw some remarkable conclusions. First of all, it's clear that any isomorphic group of curves come in batches of q divided by 2 at a time. Because this amount is of the order of q, we can conclude that there is probably a relationship between A and B, that there is, so you just vary A and B, right? And that's the way you get, for a difference A and different B, you get a different curve. Those are the curves. So there must be a relation between A and B that express one in the other, so that the total number of interesting curves is reduced by q squared to about q. I mean, A can be one of q elements and B can be one of q elements. So you could argue, well, then it's probably q squared total number of curves, but they come in batches of q. So apparently, if for a given A, the B is kind of fixed for that isomorphic curve, batch of curves, basically. Let's see. Secondly, there's a striking symmetry between curves of cardinality, the number of elements in FQ, and 2 times Q plus 1 minus that. So that's the symmetry line in the middle. There exists exactly the same number of combinations of A and B for either of the two cardinalities. Cardinality is again the number of solutions of that curve. So we can expect to also see this pairing of cardinality back in a symmetry of A and B. I won't read it all. I just want to go to the nice colors. So combining all these conclusions, you can show the same data like this. So I've got, let's see, we can make this investigation more accessible by making it visible as follows. The matrix below shows the simplest case where m is 3. Thus q is 2 to the power m is 8. Horizontally, all values of A are plotted left to right, 0 to 7. It is just eight possible elements. So this 7 here means that you have a 1 for all the coordinates of 1t, t squared, and 1t and t squared. So the polynomials have degree 2. Yeah? And then vertically, all the values of B, also 0 to 7. So the black bar at the bottom corresponds to B equals 0, for which there are no curves. And you see, even from the structure of the groups, they must be the structures of groups, right? Oh, these are cyclic groups. They're all cyclic here. You see very clearly that there is an incredible correspondence, and also you see why the total number of the cyclic group 4 equals that of the cyclic group 14, because they just alternate. And then you see also why they come in batches of Q, because, yeah, the thing is Q wide. So you have 1, 2, 3 times Q, and this is 1, 2, 3 times Q, and this is 1 times Q. And then each of them gets half of that, because it alternates. So Q divided by a half for blue, Q divided by 2, sorry, not divided by half, Q divided by 2 for yellow and blue, and 3 times Q divided by 2 for all the others. And if you do this for all of them, you get pictures that look like this. So it doesn't necessarily have to alternate, but there are the same number of greens and purples. The color does happen the same. And of course, this number 0, 1, 2 till 7 is just a binary number where every bit corresponds to a coordinate of the polynomial. So the order is arbitrary. So if they alternate here, then yeah, well, just a representation. If I toggle 2 bits, then it alternates here as well. So there's not really that much difference between it. The only thing you really can see here is that the same number. There's only 2 colors per value of B, and there's the same number horizontally. And then in the end, it turns out that, so horizontal was A, that you go from one color to the other exactly on the trace of A changes value. So the trace can only be 0 or 1, because this is for, I didn't say that yet, but the characteristic of the field is 2. So every coordinate is only 0 or 1. And then the trace is therefore 0 or 1. And then purely based on the trace of A, you have one color or the other color. And then B determines the vertical height. So I did a shitload of those. And then the next chapter I analyzed it. Yeah, I'll stop boring you with it. It might take an interesting read for someone who does know some mathematics. So A0 is a hyperplane in a multidimensional space. No. I mean, I'm talking about a binary space. So the hyperplane here is in a space where each dimension has 2 values, 0 or 1. That's hardly can talk about a hyperplane, really. Nevertheless, if you have vectors with coordinates 0 and 1, then you can still talk about 2 vectors in that space that have an angle of 90 degrees by calculating the in product, the dot product, I mean, and stuff like that. So yeah, there is a hyperplane in the sense that all the solutions that belong to the trace 0, if you subtract 2 of them, then you get a vector that lies in that plane. And then if you go between A0 and A1, so if you subtract any of those, that does have a component that is perpendicular to it. So yeah, this is then the final final find, I guess. The trace of A0 is 0 and the trace of A1 is 1, where A0 is an element of exactly of A0, which was defined as I think the solutions of the elliptic curve plus the point in infinity form a group. And if you pick, say, any A0, then think those groups are isomorphic or something like that. What I don't remember the all exactly anymore. This is from 2008. But what I do remember is that if you read literature about elliptic curves, then they seem to pretend that A and B make up a unique curve, while it is not the case. There is only cardinality 2 anyway. There are only two values of A possible. So any element of A0 is the same. Any element of A1 is the same. So basically you have only two different curves with regard to A, and not a lot. And they are just each other's what is the word? Complement. So if you have the solutions that you have for A0 are exactly the others, the x coordinates for. I mean, you have a certain. Sorry, they are not even different. You can pick either. It's just all the same. So it doesn't matter. The value of A doesn't matter whatsoever. So I thought if I can understand B also exactly, or now I call this correcting parameter B because I consider A to be completely correct here. Then then I basically correct the whole the elliptic curves. I was calculating myself rich already. My main goal was to find the number of solutions. So here you have a brute force counted the number of solutions as function of the degree of the irreducible reduction polynomial. And these are then the number of solutions. But of course, for real cryptography, this is a lot of bits, 256 bits or something like that. And brute force means that you literally have to run over all values. So 2 to the power 256 is impossible. But I still need to know how many solutions there are. Now you can write it as this, 2 plus 2 times some count. So this is the count then. And then you can split that up, or I saw that it occurred to me that you can subtract 1 from this count and then divide then m, which is in the first column, divides the result, but only if m is prime. So for all the prime numbers till 31, you can divide it by m. So I only filled in for prime m. I filled in the count, so 2 less than the number of solutions divided by 2 minus 1 now, and then you can even divide it by m. Then you get these values. And that is, I could explain it why that is the case. And then I analyze it further. That is for all non-primes. So all composite numbers. You can split them up like that. I don't think I could do that now, but I used to be smart. Even in 2008 I was still smart. Wow. Apparently. So yeah, I went ahead and I just figured out how to generate those numbers. At least a lot of them, but not all of them yet. So this was my next attempt. I think it was a kind of a dead end. I just tried it very hard. And then here, you see a certain pattern, and then you can reduce it again. You say, oh, we see this pattern, so the same data can be represented this way, which is a lot more condensed again. Okay, that did allow me to write a solution for ECT1, which is a part of my formula, in terms of, well, recursive, because it uses itself. And then I made this table where, so the number of solutions, this is what we want to know. And the green ones I all solved. And the blue one is, I think, also solved, but there's a conjecture there. And the white ones have no formula. Unfortunately, could not find that. And then anticlimax, I found how to generate it. So it kind of stops here. I could not find a formula, but I could find a program. An insanely short program. This generates those numbers that I tried to find so hard and couldn't. How short can it go? It's nothing. So what this returns is the number of elements x that have an inverse 1 over x, where x is every element except 0, that certify that the trace of x equals the trace of 1 over x. And that is related to the number of solutions of the elliptic curve, which is my invention, that the linking between the trace and the solutions of an elliptic curve and the trace of an element. So with this incredibly short program, you can just calculate as far as you want. And then I said in 2008, of course, much more analysis follow. But yeah, then I was contacted by the FBI. No, just kidding. Nothing came after that. And I'm also not going to try anymore, because in the meantime I'm 20 years old or something like that. But yeah, so maybe it's related to what you meant with the numerical stuff in C++, but it's not a numerical approximation, right? This was exact. It's just only integers, if you know what I mean. But it's definitely something I like as well, yeah. You can really use the computer to do mathematics in the sense that if you just play with it and you brute force a lot, and you graph it, then you see things that you would not otherwise discover with just formulas. Unless you're, of course, some mathematical god who is insanely good with just formulas. But I never studied mathematics. I mean, I studied physics, which also has a lot of mathematics, but nothing like a real mathematician. But you can still do a lot. if you will write programs for it. Yeah, that gives a lot of insight. Yeah, you have to ask yourself, I think, if you want to write everything from scratch, or that you want to start investigating stuff using a mathematical library that already exists. I don't know, what is autodiff? It's almost 2 a.m. I think I'm going to stop or go to bed, yeah. Thanks for hanging out, man. Maybe I'll see you around. Or, sorry I couldn't answer the question. Just Google it. Ask around and start programming. I also started. I want to go back there. So, by repositories. A while back, I started. I think when I finished with the infinite chessboard, I want to go back to. That was a long time ago, apparently. This might also be interesting. Sandbox to play with factorizing integers. Duh. You're gonna like it. I have no idea what it is, actually. This is one of my repositories. Tested to play with the partitions algorithm. Might also be interesting. What? Is that that long ago? Yeah, this one, machine learning. So I started the machine learning stuff, and then yeah, here also I start from the very bottom. I wanted to do everything myself. So these 3 readmes contain everything I learned. They should be very interesting to read, I think, if you're completely new to it and you like the way I analyze stuff. I mean, yeah. My memory is so bad that if I would not have written this, I could never have restarted the project. But if I read this, then I should be understanding again what I did and what it is, what it means. So this was backpropagation, yeah. So every fucking detail of backpropagation and how to calculate it, and written in code as well. The only code that I have for this is a lobotomized single neuron. That's what I'm working on, have been working on. So my goal in the end was to train a single neuron to be able to draw a single straight line. I mean, a single neuron is linear, right? So you have a 2-dimensional plane with points in it, and then some points are green and other points are red, and they are distributed in a sensible way. Namely, not random at all, actually. Well, random, but they say I define a distribution along a line. but distributed. So the red and green points are a bit the let's say the density of let's say the density of red plus the density of green equals 1. Yeah, and then and it's just a sigma in one direction. So you go from 100% red to 50% red, 50% green to 100% green as a sigmoid, I mean. And then because it's a two-dimensional plane, there's of course just one line that is perpendicular to this transition. And if you go to a line perpendicular to that, then the densities don't change at all. And then using that generated or known density changing sigmoid function, I generate random points, yes? So then now you have red points and green points, but secretly I know that they are distributed like that. And then I want my single neuron to be able to very quickly, what is the word? Zoom in on the correct solution. Yeah, so get the correct. It should have a picture somewhere, maybe. Yeah, it's just fun, of course. I mean, this is just. I vaguely remember I have PNGs here in data. Oh. Or maybe they were just generated by the program. But then they should be in my source tree. There's no machine learning here. What the hell? There's the machine learning. No, that's not it. It's an interesting picture, but not what I was looking for. Okay, well, I'm gonna go to bed. So good night. Have fun with your programming. Maybe I'll see you.